Good day, viewers all over the world. You are welcome to Toydel online class. Today, we want to look at some of the classification of Venn diagram. When we have just two sets, A and B. We can have more than two, we can have three, we can have four. So when we have two sets, A and B, well, let's look at the first one, where we have what we have inside what we have there. In the first one, is simply the shaded portion simply means what we have here. This is the first one. The shaded portion that we have here, it simply means A intersection B. That is where we shaded the place that is shaded here simply means where the elements that are common between A and B. That is the meaning of what we have. Then if you look at the second diagram under number 2, it simply means the shaded portion simply means A union B, because everything outside these two circles, A and B, simply means intersection between A and B. But in this case now, it's A intersection B. The shaded portion here, we are dealing with the shaded portion here, simply means A intersection B. Now let's go to the third one. We have just one element, A. Then what do we have there? We have the circle that contains A, and everything outside the circle simply means A complement. This is complement of A. So of course we know the rectangle represents the universal set. The rectangle in each case represents the universal set. It represents the universal set. From our definition, the rectangle represents the universal set. So here we have A complement. This simply means A complement. So the shaded portion in the third diagram simply means A complement. It simply means A complement. Now what about the fourth diagram? Look at the shaded portion. The only place that we didn't shade is where they overlap. This place where A and B overlap, that's the only place that we didn't shade. We did not shade. That simply means that this is A intersection B, all complements. That is A intersection B is this unshaded portion. Every other thing outside the A intersection B, where we have all this shaded portion, simply means A intersection B, all complements. Complement simply means the element that you have at the universal that are not in that set. And in that fourth diagram, that is what we are going to have. Of course, all these examples under this classification, they are just when we have two elements. We can have more than two elements. We can have more than two elements. We can also have A union B complement. That is, in case of A union B complement, let's just briefly talk about fifth diagram. When we have A, this is A, and this is B. Okay? So we can have A union B complement. A union B complement simply means A union B complement. We simply means the outer layer that we shade here. This shaded portion outside here simply means A union B complement, because A union B is either A union B simply means either you have the element at A or you have it at B or both. Then the outer layer simply means the complement of A union B complement. That's what we can also have that. Then we can also have A intersection B complement. We can have A intersection B complement. That is, we can have something of this nature. If this is A and this is B, this is A and this is A, B, then how do we represent A intersection B complement? We can do any representation under Venn diagram here. How do we represent A intersection B complement? Because this is A. If we shade this A, and all this unshaded portion simply means A intersection B complement, because B complement are the elements that we have that are in the universal that are not in B. So if you want to now take the intersection between A and B complements, that is what we are going to have. So we can actually do so many things on this. In this case now, this example, we only have two elements, A and B, but we can also have more than two elements. We can have up to three elements where we have A, B, and C. Let me just give one example on that. Where we have three elements. If this is the universal set, and there are three elements, A, this is A, this is B, here is B, and this is C. So in this case now, there are three elements that we are talking about. There are three elements. So how do we represent A intersection B intersection C? It simply means that where A, B, and C, the elements that are common to the three of them, then this is the circle of A. This is where we have elements. Now we come out to three of them. This is circle for B, this is circle of C. So if I decide to shade this portion now, this shaded portion here now simply means A intersection B intersection C. This is where all the three subsets overlap, and this will be the representation if you have to represent it in diagrammatic form. And that is what we are supposed to do. Thank you.